Hello, everyone. Welcome to the analysis update recorded on December 21st, 2021. I hope this fall semester went well for you, and I'm looking forward to working with y'all over the break and in the upcoming semester. So on the agenda for this update, I will be talking about the new diameter and the following changes that it makes for both our validation team and our design team. So with that being said, the new diameter, we are moving from 4 inches back to a 6-inch diameter. The main reason is because we found a new design that allows us to reach 30K. Irvin and Alex were messing around on OpenRocket, and they were able to get a design to 30K with a 6-inch diameter through the use of a boat tail. This is when you have a tapered off end section of your rocket, and due to base drag, which is when your wide base of the rocket causes flow separation and high pressure. If you taper that back end instead of keeping it flat and straight, like we have for all of our designs in the past, um, that taper does allow the flow to curve around more easily and reduces the size of the low pressure area behind the rocket. And in addition, this can also get us close to 30K while also receiving bonus points for payload. So leads and everyone have decided that a move back to 6 inches would be best for everyone involved. Now on the validation team side, I'll talk about the new OpenRocket and RockSim design as part of this change, and then go more into the nose cone drag calculations and determining that optimal fin shape and location. So the new OpenRocket and RockSim design, I'll take on this and hopefully have it completed by the time lab starts tomorrow. If not, it'll be for sure completed by the end of our lab time tomorrow. And then Irvin's design is what he came up with, but I know there are some slight inaccuracies and we can try and adjust a few things, move some things around, see if we can get an even better apogee. And then once I have an OpenRocket design, I'll move it over to RockSim and then update all the weights and components in there, and then upload both files to the drive once I'm done so that it can be used in reference for the nose cone drag calculations. So we do need to update that simulation for the new design. And I guess through finals and during the beginning part of break, I did realize that there is a way to actually export the full package of data from launch to landing from RockSim. So I want us to use both the RockSim and the OpenRocket data for this new nose cone drag calculation. We can have one of just RockSim, one of just OpenRocket, and maybe one of an average between the two. And then from all of these data and simulations, we still want to ask, is von Karman the correct choice? It should be noted that when Irvin was messing around with this design, he originally fitted the design with a von Karman nose cone. But after changing to an ogive, he noticed that he did gain around 1,000 to 2,000 more feet in apogee. So hopefully the nose cone drag calculations can verify that. If not, then we'll see how they respond in the simulations and with drag and make the correct choice there. Some edits to report, or some edits that need to be made to the report are changes made for the PDR, changes made for the Zenith redesign to 4 inches, and then the changes that we made for the Zenith redesign to 6 inches, along with each of those designs corresponding data and analysis. So Will, I know you've been working on this for a while, so I feel like it'd be best just to leave you up to this. And of course, I'll be there to help you along as well. Now, fin design. So something Irvin and Alex were also messing around with was the number of fins and how that affects apogee and stability. So first, I want us to determine if 3 or 4 fins is better suited for our design. I believe Irvin's current OpenRocket design has 4 fins. And then Mike, I know you utilized, I know you put together some simulations and findings in that Google Doc. from before. So continue to use those. And I'd argue that fin design is even more important than before. It has a massive effect on stability with this new boat tail. So getting this right is absolutely essential. And along with the simulations, I want you guys to think about the physical boat tail itself and any limitations that may come with it. Obviously, structures is going to be a good resource there as to, if we come up with a design, but it's not able to be manufactured, then it's pretty much useless. So we want the best possible design that can be manufactured. So think about those physical limitations as you're performing these simulations. And I think I'd recommend to define some strict boundaries, and then within that, or within those boundaries, start to optimize for what fin could be best. And then a corresponding analysis report, hopefully once we finish and formally decide on a fin design, it should be written. And Mike and Amy, if you could take care of this, that would be great. Now moving on to the design team, I'll talk about the Oberon MMM FEA. Hopefully we can finally get that off our backs. And then the Zenith CAD, and also most excitingly, I think, starting to learn CFD. So for the Oberon MMM FEA, I think at this point, we just need to maybe simplify a lot more. And I think one way that was suggested in the PDR and by Gustavo was to just look at the thrust plate and then apply a dynamic load to that thrust plate for the duration of the launch, and then maybe an impulse force upon landing. And if it can hold up against those forces, then we can conclude that the MMM is suitable for flight. And then also more forward thinking, I want Arturo and Omar for you guys to decide on another area of the rocket to analyze. Some three kind of events / areas I thought of was the boat tail itself, maybe separation of the nose cone at apogee and for the main, and the forces, I guess, interacting with that whole system, and talking to recovery about that. And then lastly, the landing event, and making sure that maybe, our screws will hold up under the impulse force of landing, and maybe also looking at the boat tail during landing. So Arturo and Omar, have full confidence that you guys can get that done. And now our Zenith detailed CAD. Not too much to say here, just because I do not know the status of where we're at with this. So an update on that would be wonderful. Other than that, I can just say continue to talk to other sub teams, make the change back from 4 inches to 6 inches, and a accurate representation of their system, along with recovery and avionics. And I know maybe helping them out with some of the CADs that they wanted to draft. I believe both of those sub teams want to start getting some CADs done of their systems. So offering your help there would be great as well. And then once you're complete with this, I want you to move on to learning CFD, which I'll talk about in the next slide. But this is for Christian and Nikolai. Now, learning CFD. So the software that we'll try to use is the Siemens Star CCM Plus, and hopefully we can all download it without any issues. But really, I just want us to start watching YouTube videos, find those learning resources, and begin to research, how can we utilize CFD? And I think the biggest question here is, how can this help the team? So Jacob, I'd like for you to start thinking about areas to analyze. Off the top of my head, just the nose cone and the base drag come to mind. But also, interestingly enough, in a kind of separate application of CFD, I know SRAD Propulsion was looking into how they can incorporate the liquid side of their hybrid motor or hybrid engine, and using CFD to determine some things on that end. So I think the priority is obviously Zenith, but any help we can also offer to SRAD propulsion in the future would be great for the team down the line. So Jacob, if you could get a head start on that, and then Christian and Nikolai, once you finish up your Zenith CAD responsibilities, moving over to CFD would be wonderful. So now just closing it off with some action items. So Will, as I mentioned, taking care of the nose cone drag calculations open on using both OpenRocket and RockSim. So I'll help you out with that. Mike and Amy looking at the boat tail fin design, and Arturo and Omar looking at that dynamic analysis and load on the thrust plate for the Oberon MMM FEA, and then starting to think about other areas to analyze. Christian and Nikolai, a status update on your Zenith CAD and continuing to talk to other subteams and developing those models, and then moving over to help Jacob learn CFD. And then lastly, with Jacob starting to learn CFD, I want you to focus on finding learning material for the team, and then also starting to think about areas to analyze. So thank you guys for watching. As always, if you have any questions, you can DM me or throw them in the Discord. And I'll see you guys tomorrow at our lab, which is 12 to 2 p.m. now. So see you tomorrow. Thank you for watching.